Okay, for chapter 2 of General Physics 1, we are going to talk about kinematics. This presentation will discuss mostly of the terminologies in kinematics, the basic terms that we need to understand before solving some applications or problems in kinematics. The word kinematics is actually the study of bodies in motion without considering the interaction that influence the motion. Okay. In other terms, kinematics or may also mean the studies of bodies in motion. So we study everything, everybody, anybody. When we say body, it's an object. It may be a human, a ball, anything, any body. The study of bodies in motion. So that is a requirement for kinematics. It should have emotion. However, we will not consider the forces or the interactions that causes the motion. So in kinematics, we are only dealing with how objects or bodies move, and we are not considering the forces that make them move. If we consider the forces or the interactions that influence or that causes the motion, the term that would fall under kinetics. Okay. But for our discussion, we are only going to study kinematics. So never mind the forces or the interactions that causes the motion. So we are going to begin with the basic terminologies or the terms that we need to understand in kinematics. Of course, let's start with the term position. Okay. A position is any location of a particle. Position is location kung saan nakalagay yung um, particle natin, okay, with respect to a chosen reference point or a frame of reference. Okay. For our discussion, ang magiging reference point natin is always the origin of a coordinate system. Yun yung magiging reference point natin, the origin, the 0, 0. So that eh, mas mabilis mag-plot na lang. So we can locate the position of any object in our discussion to be point X from with a distance or a certain distance with respect to the reference point, which is the origin. So still we are going to use the Cartesian or the coordinate system here. So basically, position tells us the location of a particle or an object or a body with respect to our reference point. Yun lang naman yun. Kung saan siya nakaposisyon. So kung yung literal na pagkakaintindi natin ng position, yun din naman yung ibig sabihin ng position sa kinematics. But we need to clarify what is our reference point or frame of reference dito. So for our discussion, ang reference point natin is the origin of the coordinate system. So for example dito, so a car is moving from point A to B and then C to D to E to F. Okay. If we consider yung signboard, if we consider where the signboard is, yung limit na 30 kilometers per hour, to be our zero reference point or yung origin natin. So one dimension lang tayo, x-axis lang. Okay, one-dimension motion. Hindi pa natin i-consider yung y-axis. So, horizontal axis lang tayo. If we consider 0 be the origin or 0, we consider yung limit na signboard to be our 0, then our position A with respect to this point is 30. Our position B is maybe around 55 meters. Our position C in the second image or figure is maybe 40. So, hindi naman siya specified, pero along 40 meters siya. Position D is exactly at the 0 or the reference point. So, 0 meters. E is negative 40. Negative 40 kasi before siya. So, ang convention nito is, if it is to the right of the origin, positive siya, positive distance, or yes, positive position. Then, if it's to the left of the origin, negative. Parang ganun lang din sa Cartesian plane natin or coordinate system, rectangular coordinate system. Pero yun nga lang, one dimension lang tayo, kaya x lang yung kinoconsider natin. So, position E is negative 40 because it is 40 meters before or to the left of the 0, the reference point. And F, of course, is 50 or somewhat nasa negative 50 meters. So, yun po yung mga position. Ito yung tinatawag natin position A, B, C, D, E, and F with respect to the 0 o yung origin natin is yung signboard na limit na 30 kilometers per hour. Okay. Meron pala siyang specific. So, at the beginning, so at time t equals 0, initially, the car is at point A, which is 30 meters to the right of the signboard, kaya positive 30 meters siya. After 10 seconds, lumipat siya sa point B, which is 52 meters to the right of the signboard. So, that is 52 meters. Then, after 20 seconds, nandun na siya sa, 38 meters. Umatras siya ng konti, no? Kasi from point B, 52 meters, umatras siya, nagpunta siya ng 38 meters to the right of the signboard. After 30 seconds, nandun na siya sa point D, which is exactly, nasa tapat siya ng signboard, so 0 meters yon. After another 10 seconds, nandun na siya sa point E, which is 40 meters to the left, so negative 37 meters to the left, or 37 meters to the left ng 0, kaya negative 37. And then, after 10 seconds ulit, nandun na siya sa point F, which is 53 meters to the left of the signboard or negative 53 meters dun sa coordinate system natin. So, kapag pinat natin yung position versus time, makakapag-form tayo ng, of course, yung tinatawag nating position time plot. Yan. And this is the plot or the graph nung sasakyan kanina, wherein yung 0 is, yung 0 meters, yung reference point natin is the origin. So, plinat lang niya isa-isa yung mga positions, and then nag-create siya ng graph that best represents or fits these 5 or 6 points within the span of 50 seconds, from 0 to 50 seconds to. Okay. Next term that we should understand in kinematics is the word displacement, or in notation natin is delta x. When you say displacement, it is the change in position in some time interval. So, kung meron kang position, for example, initially, nandun ka sa point A, kanina. And then after some time, nandun na siya sa point B. Ibig sabihin, yung car natin, yung kotse kanina, nag-undergo siya ng displacement because there is a change in position in some time interval. And then after 10 seconds ulit, from point B, pumunta siya sa point C. Again, merong displacement. Okay. Sir, anong pinagkaiba nung displacement sa distance? Kasi ang distance is also a difference between 2 points. Tama? Eh, ganun din naman yung displacement. So, anong pinagkaiba nila? Basically, displacement is a vector quantity and distance is a scalar quantity. So basically, if you are asking anong difference ng displacement and distance, basically you are also asking anong pinagkaiba ng vector sa scalar quantities. And di ba napag-aralan na natin yun sa chapter 1, ang vector quantity po ay anong meron? Meron siyang magnitude and then meron din siyang direction. Whereas, yung scalar quantity, meron lang siyang magnitude. Therefore, kapag tinanong mo, what is the difference between displacement and distance? Basically, displacement has a magnitude and direction, and distance has only magnitude. Displacement is a vector quantity, distance is a scalar quantity. Ganun lang po yung difference nila. So, ibig sabihin, they are not the same. They are different. Minsan kasi napapag-interchange yan, no, natin. But in physics, displacement is different from distance. So, mahalaga na ma-establish na natin ngayon yan at maintindihan na natin. Okay, for example, okay, may isang basketball player. Tumakbo siya. Gaano ba kaluwang yung length ng ng isang basketball court, yung standard?
94 by 28.
Ilan meters or feet? Siyempre, hindi naman 94 meters. 94 meters, tama ba? So, yung length nito, 29 meters. Tama. So, para ma-establish lang natin yung difference niya. So, for example, si Michael Jordan, ang luma. May isang basketball player na lang, huwag na natin pangalanan. Tumakbo siya. So, galing siya dun sa kabilang ring. Then, tumakbo siya. Hindi ata kita yung white. Yeah, blue. Nandito siya sa kabilang ring. Then, tumakbo siya dito. So, sa kabilang ring, that is 29 meters. And then, bumalik lang din siya. So, kung ang reference point natin is yung yung initial point niya, which is yung nasa kanang ring. So, anong distance na na-cover niya? That is, ang na-distance na na-cover ng basketball player is, of course, 2 beses na 29, di ba? Kasi 29, papunta dun sa kabilang ring, and then bumalik siya. So, that is 29 plus 29.
58.
Yes, 58 meters. Pero anong displacement niya? Anong displacement ang na-cover niya? 0. Bakit? Kasi bumalik lang din siya sa dati. Okay? Kapag displacement kasi, sabi nga natin, it is a vector, so we consider the direction. So kung ang reference point natin is yung nasa kanang ring, then nag-move siya papunta sa kaliwang ring, that means that is negative 29 meters. Kailangan i-consider mo yung direction. Bakit siya negative 29 meters? Kasi nasa left side siya. So, yun yung convention natin. If nasa left ka ng reference point, negative ka. Sa right side, positive. So, dahil nag-move ka to the left, negative 29 meters yon. Then, nung nandun ka na dun sa kaliwang ring, nag-move ka naman to the right. Bumalik ka dun sa dati. Tama? So, another, positive 29 meters naman. Kasi yung movement mo naman is from left to right. Papunta ka namang right. So, positive 29. And kapag inad mo yan, 0 meters. So, ang displacement ng basketball player is 0. Pero yung distance niya is 58 meters. Yun yung kaibahan ng displacement sa distance. Displacement, you need to consider the direction because it is a vector quantity, magnitude, and direction. At ang convention natin sa direction, if you are to the left of the reference point, negative. To the left. If you are to the right, positive. Maliwanag po ba?
Yes.
Okay. So, yun yung difference lang. So, I hope hindi nyo na sila gagamitin as a synonymous term, no? Kasi magkaiba sila. Okay. Ayan. Distance is the length of path followed by a particle. Distance is always positive kasi nga magnitude lang siya. While displacement can be either positive or negative, depende sa direction. And of course, distance is scalar while displacement is a vector quantity. So, balik tayo dun sa given example natin, yung kotse. Ayan. Ano ang total displacement niya? Ang displacement, di ba, is delta x. Displacement is delta x. Anong formula ng delta x? Nakalagay kanina doon. Final position minus initial position. So, anong displacement ng car natin? Ang initial position niya is at 30 meters. Dito yung initial position niya, point A. And then, ang kanyang final position is at point F, which is negative 53. So, ang displacement niya is equal to negative 53 minus 30. That is equal to
negative 83.
negative 83 meters.
Negative 80.
That is the displacement. Total displacement. How about the distance? So, if we are talking about distance, ang gagawin natin is i-compute natin yung distance every point. Yung distance na na-cover niya from A to B, from B to C, from C to D, from D to E, and from E to F, tapos i-add natin silang lahat. Okay? Remember that it is always positive. So, let's start with from A to B. Here, from 30 to 52 yung position niya. The distance between A to B is 52 minus 30. So, I'll write it on top. Distance AB is 52 minus 30 plus B to C. That is 52 minus 38 plus C to D. That is 38 minus 0 plus D to E. D to E is 0 minus 37. So that is 0 plus 37. Then from E to F, that is negative 37 minus negative 53. So it becomes positive 53. Okay. Baka nagtataka kayo. Maybe you are wondering, sir, bakit?
So in AB, Should it be 30 minus 52?
Okay. Yes, I was going to say it. Okay. Um, maybe you are wondering why is it in AB inuna ko yung 52. 52 is the minuend or nauna si 52 pero pagdating kay dito sa DNF na, okay? Because dapat positive lagi. The distance between AB is positive. So you can rearrange this. Actually, there should be a positive, an absolute value between them. But di ba pag absolute value, it is the same as kahit pagbaliktarin mo lang si x1 and x2 and you take the absolute value, you get the same answer. So my trick here is that if you are looking for distance, no, just arrange the two positions in a way that you get a positive number or a positive result because this is always positive. So um the positioning of the order of positions here, the positions here is not really important. What important is that you should get a positive result. Did you get it? So make sure that
Yes.
okay. So that's why here in AB, nauna si 52, 52 comes first, while in DNE, 0 comes first. Because it should be positive. So make a way that the answer should be positive. So 52 plus 30, that is 18, minus 30, sorry. 52 minus 30 is 18. 52 minus 38 is what? 14? 38 minus 0,
16?
16 ba? 14.
Sorry.
38 minus 0 is 38. 0 plus 37 is 37. Negative 37 plus 53 is 16. Then you add. Okay, I don't have a calculator here. I guess I should mentally add this. But I can, so I'll write it here. Sorry. So we have 10, 26, 33. So 3, carry 3. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Sir, yung AB,
Oh,
52 minus 30, 18?
Sir,
ay sorry,
22
22.
ata.
Sir, di ba 22?
Hubot ko nang gagol.
Ay, sorry.
Sorry, okay. It's 22. Sorry, sorry. 10, 10, 20. Tama na ba? Wala na bang mali? 10, 27, carry 2. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. 127. Is it correct? Can you
Hindi
please?
na paniwalaan si John.
Yes, sir. 127 po.
Okay, please double check. So the distance is 127 meters. So one thing also that is the difference between displacement and distance. Si displacement, ang kailangan mo lang is the two endpoints, which is the final position, point F, and the initial position, point A. Hindi, wala na siyang pakialam. No, we don't care actually where did the body or object went between the initial and final position. Displacement is only cared about the initial and final points of the object. However, in distance, we are required to track down where the object went between the initial and final position. Okay, every path that the object went, kailangan nating i-consider. Yun ang difference din ng distance and displacement. Si displacement, una at huli lang. Okay, pero si distance, kailangan, pati yung mga pinuntahan pa niya, i-consider mo pa. bago siya makarating dun sa final point. Forwards and backwards is the same as left and right as long as it is within the horizontal axis.
No, as in, what happens if you combine those two, both forward, backward, and left and right?
Okay, you mean we have two-dimensional motion?
Yeah.
Okay, that is still going to be our next topic. Maybe that will be in the next meeting next week or after the exams. So for today, we are only considering one-dimensional motion, as you did see in the title. We are only considering first one-dimensional motion. Okay?
Okay.
Okay. Let's move on. So now what terms have we already discussed? We have the position, we have distance and displacement. So this time, okay, sorry. The average velocity. Velocity has two types, okay? First is the average velocity and later on, the instantaneous velocity. The average velocity of a particle is defined as the displacement divided by the time interval. So basically, displacement all over time. That is the average velocity. Sometimes, more often than not, it is expressed as xf, final position, minus initial position because this is the definition of delta x or displacement, right? Yun yung formula natin. Divided by delta f, uh, sorry, time final minus time initial. Kadalasan naman, si time initial, kadalasan naka zero yan lagi. Zero, most often than not is our initial time. So, minsan, hindi na siya delta t. Sometimes the authors of other books only write a single t, which means the t, the time here, it is the final time. Since the initial time is usually zero or reference to 0 seconds. But basically, velocity or average velocity means the displacement all over time interval. Okay. Average velocity, of course, because displacement can be positive or negative, and because velocity is displacement all over time, therefore, average velocity also has a positive or negative, or can also be positive or negative depending on the sign of the displacement. Between any point. So, for example, between points A and B, let's find the average velocity between A to B, or from point A to point B. So our point A is 30 meters, right? 30 meters at time t equals 0. So this is our initial point. And for point B, ilan na ito kanina? 52. So 52 meters. And that is after 10 seconds. So from A to B, the average velocity is just displacement divided by the change in time. What is the displacement? That is final velocity minus, final position minus initial position all over final time minus initial time. Since we are considering from points A to B, so our final position would be point B and our initial position would be point A. So ang XF natin, our final position, is equal to 52 meters minus initial position 30 meters divided by final time 10 seconds minus initial time 0 seconds. So that is equal to 52 minus 30, 22 all over 10 seconds. So our average velocity from A to B is 2.2 meters per second. You can also compute if you want from A to C, from D to E, any point. Okay, if you want from A to F, so the average velocity is equal to displacement all over time. Ano yung nakuha nating displacement kanina from A to F? That is 127, right? If I remember it correct. Para hindi na tayo mag-compute. Kasi kinumpute na natin kanina yung delta F, ay delta X, which is the displacement from point A to point F. Then, i-divide na lang natin yung delta at T. What is the time interval? Point A is time T equals 0. Then point F is here. Time T equals 50. So the change or the time interval is 50 minus 0. So that is 50 seconds. 127 divided by 50, that is 2.54 meters per second. Meters per second. Is it positive or negative? Okay, mali. Yung displacement natin, 127 is the distance. Oh, you did not correct me. Ano yung displacement natin kanina?
87.
Okay, is it positive or negative? 87 ba o 83? I think it's negative 83.
Negative.
Negative 83, right?
Sir, yes, negative.
Yes.
Displacement yung hinahanap. So, negative 83 divided by 50, that is negative 1.72. Okay, please correct that. So, our average velocity from point A to point F is negative 1.72. Again, velocity kasi is a vector quantity. So it can also be positive or negative depending on the sign of or the direction of the displacement. Since yung displacement natin is negative, so negative na rin yung velocity. Since velocity or average velocity is displacement all over time. Any questions?
No.
Okay. None? Just 0.54. So, yung average speed from A to F based on our example natin kanina, yung distance na ating na-compute is 127 meters divided by 50 seconds. Yun yung interval from 0 to 50. So that is 2.54 meters per second. This is the average speed. As you can see, it is different from the average velocity nga kanina. Any questions? None? Okay, let's have some other examples. Okay, here. Ito na rin pala yung kinuha. Find the displacement, average velocity, and average speed of the car between positions A and F. So, actually, ito na yung na-solve natin kanina. So, if displacement, okay, solve pa rin natin. Displacement is delta X. That means it is xf minus xi. The final position is point F. Initial position is point A. Point F is located at where? Negative 33 meters minus initial position is, oh, sorry, 53 pala. 53. Negative 53 meters. And initial position is at 30 meters, point A. Yun nga. Yun nga yung nakuha natin kanina na negative 83. Naulit yung example ko. This is the displacement. And if you want to find the average velocity, it is simply the displacement all over the time interval. Na-compute na natin yung displacement. So, automatically, negative 83 meters yan. And the time interval between point A to point F is 0 to 50. So, that is 50 seconds. So, yun nga po yung 1.66 meters per second. Negative siya kasi negative yung displacement. And yung average speed, na-compute na natin kanina, that is 2.54. Nawala ng internet. Salita ako ng salita dito. Trip. Okay. So, basically, yung further example nito is same lang dun sa ginawa kong example kanina, which is point A to point F. So, na-solve na natin yung example na to. Let's see if meron pa tong ibang example. Okay. Okay. Binigay niya lang yung solution. Remember that average, i-remember nyo rin yung notation natin, no? Pag average velocity, ganyan siya. Meron siyang x. Displacement is delta x. Pag distance, yung notation natin is d lang. D. D for distance. Pag displacement, delta x. Pag average velocity, meron siyang x, average, avg na subscript. Whereas, if speed, avg lang. Average. V avg. This is the average speed. Paki-take note yung mga notation natin para hindi tayo naguguluhan. Slide. Yan. If we want to find the average velocity, diba, ang kino-consider lang natin is displacement all over time. And displacement only considers the two endpoints, yung final and initial position. Like for example, if we want to find the average velocity between A and B, so ito lang yon. A and B lang yung i-consider natin. Hindi nakikita yung kulay. So I'll choose red. Okay, here. 2 points. 2 points yung kailangan natin kapag average velocity. Now, we have the final and initial positions. 2 positions. Sa instantaneous velocity, delta x all over delta. Okay. What if, sabi niya, what if yung time interval natin, dito sa average velocity, ang time interval natin between A to B is 10 seconds. So, what if yung time interval natin is niliitan natin ng niliitan? That is, kunwari yung B natin is na-adjust. Yung point B is adjustable. Okay? In such a way na palit na tayo ng palit, yung time interval natin approaches 0 na. Yung halos magkasing dikit na sila. Okay, ano na ngayon yung magiging velocity natin doon? So, kapag ginawa natin yun, if we find the limit of this delta x all over delta t, as delta t approaches 0, ang nangyayari is nagkakapag-form tayo ng tangent line to this curve. That tangent line, of course, dahil tangent nga, will touch the curve at one point. One point lang ang kailangan mo or one position lang ang kailangan mo para makuha sa instantaneous velocity. Tinatawag din siyang tangent method. Si average velocity dahil 2 points, second naman ang tawag. Kasi second line ito eh. Because it intersects the curve at 2 points, second. Si instantaneous velocity, 1 point lang, tangent. And alam ko, hindi nyo pa nakukuha yung basic calculus nyo, second sem pa yun, pero the limit of delta x all over delta t as delta 3 approaches 0 is actually, ang kailangan lang natin maintindihan dito is yung difference ng instantaneous velocity and average velocity. And I guess, na-discuss na natin, nasabi ko na, ang difference niya is that instantaneous velocity is the limit of delta x all over delta t as delta t approaches 0. Or it is the limit of the average velocity. Diba? Si delta x all over delta t is the average velocity. So, the limit of average velocity as delta t approaches 0, that is actually the instantaneous velocity. So, skip this example. Yan. Vx delta t equals xf minus xi. Transpose xf to the right side or left side, so it will become positive. Therefore, xf is equal to xi plus vx delta t. So, ito na yung. So, this is the only formula for particles under constant velocity. For particles under constant velocity, you can only know yung final position niya. Kasi wala naman ng ibang nagbabago. Kasi nga, yung velocity naman, constant, hindi nagbabago. Yung time lang din ang nagbabago. And because of the change in time and the constant velocity, magbabago din yung final position natin. And actually, if we graph x all over time, under constant velocity, the graph is a straight line. Kasi, yun nga, constant yung velocity natin. The velocity is actually the slope. You see, if we plot x, t, di ba, kung maalala nyo yung dun sa ating x and y axis, tapos meron tayong line, the slope of the line is y2 minus y1 all over x2 minus x1, or that is change in y all over change in x. But this time, yung under motion in one dimension, yung y-axis natin, yun yung naging x, which is defined as the position, and the x-axis is defined as the time interval. Therefore, wala siyang pinagkaiba sa slope na alam natin na delta y all over delta x. So, delta x all over delta t is actually the slope of the line, or velocity, vx, is the slope of the line, or the graph, or the plot of position versus time. And if the velocity is constant, the graph is a straight line. If the velocity is constant, tandaan nyo, ang graph natin ng x versus t is a straight line. Okay. Let's have an example for particle under constant velocity. Wala. Wala akong ano. Wait lang. Wala kasi akong space for solution. The velocity so the problem states that magsisimulang tumakbo at a constant rate yung ating experimental subject. So, sabihin na natin dito, point A. Sabihin natin point A, yun yung initial point niya. And then, magsisimula din yung time niya dito, which is time t equals 0 seconds. Initial point, 0 meters. Then, after that, tatakbo ngayon yung experimental subject at a constant rate. And then, titigil ngayon yung ating stopwatch kapag na-reach niya na yung point B. And that is the final position, which is 20 meters away from the initial point. And yun nga, ang na-measure nga nung kinesiologist is that after 4 seconds, maaabot niya yung point B. Ang tanong, letter A is, ano daw yung velocity? Since sabi niya naman, constant rate yung pagtakbo. Diba? Anong formula natin for velocity? We have delta x all over average to all over delta t. Actually, hindi na to average kasi constant velocity siya. So, ang delta x is equal to final position minus initial position all over final time minus initial time. Final position is 20 meters. Initial position, sinet natin as 0 meters. Final time is 4 seconds as indicated by the stopwatch. And then, 0 seconds, of course, nagsimula siyang tumakbo. So that is 20 all over 4 meters per second, or the constant rate is 50 meters per, or 5 meters per second. Yan yung constant velocity. Okay, dun sa question B, any questions for part A?
None at all.
Okay. For question B, sabi niya, it says that if, for example, after passing point B, still the experimental subject is still running at a constant rate, which we determine to be 5 meters per second. After passing point B, the experimental subject still run for still run for 10 seconds. So tumakbo pa rin siya. Okay? He did not stop at point B. Instead, still run for 10 seconds. So that means 10 seconds after this point B. So we got 14 seconds here. The question is, how far will the runner or the experimental subject be? So from our derived formula, the only formula for particle under constant velocity is that the final velocity is equal to the initial position plus the constant velocity times the change in time. Our initial position is 0 meters, so that is 0, plus our constant velocity as we determined from part A is 5 meters per second. So we multiply 5 meters per second to what is the time interval? That is 14 seconds minus the initial time, which is 0 seconds. Therefore, our answer would become 5 meters per second multiplied to 14 seconds, that is 70 meters. So the runner will be 70 meters from the initial point, which is point A. Any questions? So recap natin yung mga napag-aralan nating ano. We have the position. And if a particle changes position, magkakaroon siya ng displacement. And then kapag nagbago naman yung displacement niya with respect to time, nagkakaroon naman siya ng velocity. Tama? Kasi ang displacement is delta x. Ang velocity is delta x all over delta t. Ganon yun. Kapag nagbago po yung posisyon, magkakaroon ng displacement. Pag nagbago naman yung displacement in a time interval, magkakaroon naman siya ng velocity. So what if yung velocity naman ang nagbago?
So, isn't delta x supposed to be distance?
No, d is a distance. That is our notation. Our delta x is our notation for displacement. D is for distance, to avoid confusion. Okay? So sabi ko nga, kapag nag-change yung position, there is displacement. If displacement changes over a time interval, meron siya yung velocity. What if yung velocity naman ang nag-change? What if the velocity changes all over a time interval? Magkakaroon naman tayo ng tinatawag nating acceleration. Acceleration is the change of velocity or change in velocity over a given time interval. Yan. So if there is no change in velocity, then there is no acceleration. If there is no change in displacement, there is no velocity. If there is no change in position, there is no displacement. Para siyang domino effect. Pag nagbago yung position, may displacement. Pag nagbagong displacement, may velocity. Pag nagbagong velocity, merong acceleration. And also, the same way as velocity, acceleration has also two types. Meron tayong average acceleration, and meron din tayong instantaneous acceleration. And the difference is pretty much the same as that of the difference between average velocity and instantaneous velocity. For average acceleration, that is delta v or delta velocity all over delta time, or that is final velocity minus initial velocity all over final time minus initial time. Okay. I have to clear something here, which is what we mean by, or what the term negative acceleration means. Okay, negative acceleration, because acceleration is a vector quantity, right? And since it is a vector quantity, it has a direction and a magnitude. Therefore, acceleration can be negative or positive. Okay. But negative acceleration doesn't mean or doesn't necessarily mean that an object is slowing down. Okay, hindi porket negative yung acceleration, bumabagal yung object. Okay, if the acceleration is negative and the velocity is also negative, that is, if the acceleration and velocity are in the same direction, the object is actually speeding up. Bumibilis talaga. Bumibilis siya. Okay, so tanggalin natin sa isip natin that negative acceleration means it is slowing down or the object is slowing down. It is not always the case. Although, pwede naman, pero hindi laging ganun. Kagaya nga, kapag the acceleration's direction and velocity's direction is the same, mag-speed siya. For example, okay, a car moving to the left, because it is moving to the left, its velocity is negative and also accelerating to the left. Then, bumibilis siya dito sa direction nga lang ng left. So, what is important here is that you understand that negative acceleration doesn't necessarily mean that an object is slowing down. And also the term deceleration. Okay, when we say deceleration, yun yung ibig sabihin ng slowing down. And negative acceleration is not the same as deceleration. Okay? Deceleration, automatic, yun yung reduction in speed. i.e., a slowing down. Ito talaga yung bumabagal. Kasi nababawasan siya ng velocity. Okay. Instantaneous acceleration is also as what instantaneous velocity is. It is the limit of the delta v all over delta t, or the limit of the average acceleration as delta t, or the time approaches 0. And just like nung sinabi natin that when we plot xt, or if we plot the position of an object over a time interval, and we said that delta v, or v, is the slope of the line, that is also true with acceleration. If we plot velocity versus time, the slope of the curve is also the velocity or the acceleration. Velocity is the slope of the position time plot. Okay? Velocity is the slope of the position x versus time graph or plot. On the other hand, acceleration is the slope of velocity versus time plot. So again, this is example for instantaneous velocity, which is again requires a knowledge on basic calculus, specifically on deriving functions or first derivative of functions. So we are going to skip this example. So we are now going to end this discussion. We will discuss particles under constant acceleration after the exam. So our exam will only be about vectors, scalars and vectors, specifically determining the resultant vector, and then the definitions, the terminologies on kinematics. We have position, displacement, how to determine the displacement, average velocity in instantaneous velocity, and how to get the average velocity, and then average acceleration and instantaneous acceleration, and also how to get the average acceleration, and particles under constant velocity. So hanggang dun lang ang ating first exam or prelim exam.